Good afternoon, everybody. I am Professor Sula Luca, and I am at the University of Nicosia, the Department of Digital Innovation, and one of the directors at the Institute for the Future. Thank you for joining us this afternoon in the first MOOC organized within the framework of the European program EUNOMIA, a program funded under Horizon 2020 on decentralized social media and misinformation. Today, we will have an introduction on blockchain technologies and then a presentation and a discussion as well on the blockchain infrastructure that we designed and developed within the framework of the program at the University of Nicosia, as well as the governance model that is being used. But please allow me first to say a few words on the project itself. So let me share my screen. I'm hoping that everybody can see it. Is the screen shared? I assume yes. So, all right. Now, we all know that fake news is not actually a new phenomenon. And the first occurrence goes back centuries ago, even though the most recent one recorded, it goes back in the 19th century. And to top it up, of course, in terms of misinformation, the information era and digitization, and because of the way that the easy spreadability of information, we have an exponential increase at the rate of which fake news flourishes, due to, as I said, to the easy spreadability of information and data. So EUNOMIA actually is a social environment that, as I said, we have developed within the framework of this program that supports users to assess the trustworthiness of the posts that are being shared. In this way, it can reduce the spread of misinformation at the source or near the source. It technologically guarantees that no entity can manipulate the information displayed to the users or decide on their behalf what is trustworthy and what is not. The main objectives of the project is to assist social media users to identify the source of information, to assess the provenance of online information, and also to protect their network from misinformation. So we are looking within EUNOMIA into at a fully decentralized peer-to-peer platform where blockchain ensures the integrity of the P2P processes. And in addition, we are using AI to help identify and analyze information cascades. This information cascade can be visualized, and associated trustworthiness indicators can be chosen by the user. But of course, more we will find out on the blockchain infrastructure as we go along within the next hour or so. The way it works is that users, when they sign to the network, give their consent to have their posts analyzed by EUNOMIA. For every post, its AI informs users whether it has found similar older posts, as well as contextual information in terms of the post's sentiment, subjectivity, and other aspects. In addition, the users are also asked to indicate themselves whether they trust the post or not. Of course, we will share with you our testing environment that you can actually try this yourselves. So today, as we have already mentioned, we are going to see what's under the hood in terms of the blockchain infrastructure used, as well as the governance model. Dr. Elias Yosif, a colleague of mine at the University of Nicosia, will be having a short introduction for us on blockchain technologies and what they are all about. And then Dr. Klidos Christodoulou, another colleague of mine, and actually the coordinator, the PI on behalf of the university for the EUNOMIA project, will be presenting to us the blockchain infrastructure and the governance model. So we will be sharing, as I said, with you the testing environment, which is currently integrated with Mastodon, so that you can test it yourself. And so I will, EUNOMIA is for, I would say myself, everybody who is interested in social media and ensuring that what they share is not actually misinformation. And here we see all the different partners that we have, ranging from the University of Nicosia to INOV, the University of Greenwich, who is the coordinator of the project, Mastodon itself, ORF, Simavi, Civeco, INOV, Trilateral, and Blasting News. So thank you. And I will pass the floor now to Elias to introduce us to blockchain technologies. Thank you, Leon. The floor is yours. And let me stop sharing.
Thank you, Shula. Also, welcome from my side to everyone. Can you see my presentation? Is it visible?
Yes, Ilya.
Yes.
Thank you. Before starting, let me say that this part of this MOOC is supported by the Erasmus Plus DLT for All project, which is coordinated by the University of Nicosia, having a consortium being a mixture of members from academia and industry. The basic idea behind DLT for All, as the name suggests, is, among other things, to produce educational material for bridging the gap between academia and industrial needs. And based on this spirit, we are using in this part, or in this introductory part, some introductory slides. So without any further delay, in this part, we are going to see a very quick introduction to blockchain, a historical overview, as well as the basic technological components. We are not going to give an exhaustive coverage of the topic. This would require many hours, of course, but this is to illustrate the following progression, that blockchain started for a specific application in mind, doing electronic payments in a decentralized way. And the important thing is that the capabilities are now generalized. And one of those applicabilities is illustrated for the EUNOMIA case, where Dr. Christodoulou will talk about later. But let's see why and how this idea of cryptocurrencies and chain blocks has started. So, as you probably know, the milestone number 0, the starting point of blockchain, is the year 2008, where a short technical paper has been published, authored by Satoshi Nakamoto. Satoshi Nakamoto is an imaginary name, but this does not matter. What matters is the ideas, or to be more precise, the combination of the ideas included in her, we don't know, paper. So almost immediately, the world of industries recognized the potential of this technology, and have started the exploration of the respective applications. One major characteristic of this seminal work of Satoshi's paper is not the novelty of the constituents ideas mentioned in there, it's their combination. To put it differently, already known ideas and techniques from the area of mathematics, computer science, and related disciplines have been brought together in a unique way. Actually, they are engineered, I would use this terminology, in a way that make blockchain a powerful application. Some of the key characteristics of the blockchain, referring, of course, as I mentioned, when we are dealing with the early stages of blockchains, we refer to Bitcoin, is that Bitcoin and many similar other blockchains are decentralized. That is, the assets, or in general, the digital entities that are stored into blockchain have not a central issuing party. The creation of those assets is done algorithmically. That is, we have a computer program that creates those assets. All things are digital, and by extension, the currencies created are supported by strong cryptography. Okay, I assume that the majority of those characteristics are already known, but I would like at this point to ask if there is any question about those basic characteristics, to make sure that we all understand at least the very basics of these ideas. Any question? I guess no. So another way to see blockchain, and specifically Bitcoin, is to explore its respective innovative profile. We can fairly claim that Bitcoin has two innovations. The first one deals with the store of value for people who wanted an alternative, open, transparent financial system. This is the first one. And the second is the fact that through Bitcoin, a new way is developed for open decentralized networks according to a broader sense. This means that if we have a way to represent cryptocurrencies, digital currencies, we can easily extend this idea for representing other entities which can have value for some communities. one may see a direct relation with recent development in the area of blockchains, NFTs, non-fungible tokens. Okay, this is quite well beyond this the scope of this presentation. But you know, as far as you have things in a digital form, you can easily you know, generalize ideas, combine different representations, etc. So then digitization is in general powerful, enabling all those characteristics, open, decentralized systems that, among other things, can be financial systems. But not only this, as Klitos will explain, the value, the importance of blockchains nowadays has evolved and went beyond the financial domain. This is one of the main message of this introductory part, and this is, I think, of key importance to understand that blockchain is not only for bitcoins and cryptos. So let me do an interesting historical overview, starting by 2008, when we have the publication of Satoshi's white paper entitled, this is an interesting title, Bitcoin, a peer-to-peer electronic cash system. I would say that the most important word or term in this title is the three-word term peer-to-peer, meaning that all nodes, entities that are participating in this network are of equal, let's say, authority importance. Just to give the basic idea, is follows the ideas of peer-to-peer networks that is very well studied and remains to be an open research area for the field of distributed systems. That's why I was saying that the constituent ideas of Bitcoin come from other disciplines of computer science and related fields. 1 year later, in 2009, the first Bitcoins are mined. An interesting story is that in 2010, a Bitcoin user holder bought the 2 pizzas, spending a considerable amount of Bitcoins. Today's price would be around, I don't know if this price is updated, but the meaning is that in today's prices, those 2 pizzas value many millions of euros. Interesting to see how things evolve. In 2013, we have the first Bitcoin fork. Fork refers to a condition where the network splits into some alternative part. Those parts come with the respective communities. So no need to enter into details, just to say that the creation of blockchain variants is possible, has been done many times, and it's up to you to choose which one to follow according to your needs, beliefs, predictions, etc. Also, as expected, we had some fraud, some also attacks, some not so good situation. So in 2014, we have an incident where investors lost cryptos. In 2015, we have the creation of new coins. The most notable case is the case of Ethereum. And again, we have more forks, more attacks, etc. The interesting thing is that I would say that the last 3 or 4 years, government and other similar institutions realized the importance of those technologies, and has started a long ongoing discussion internally at the national level, at the European level, involving stakeholders from the private and public sector about how to deal with those new developments. This is aligned with the fact that, in industry, the advancements are more faster compared to the advancements that happen at the governmental side. So governments have realized that something important is going on in this space, and they have started the discussions how to deal with it, regulate it, etc. And up to this point, up to nowadays, all those discussions and development are continuously. We have the creation of new coins, variations of those coins, new ideas around the broader concept of digital assets like the non-fungible tokens, etc. Overall, is something that that becomes bigger and bigger day by day. So regarding Bitcoin, a natural question is whether Bitcoin is a currency. Yes, it's a form of digital currency, which can be created and stored electronically on a computer. Obviously, Bitcoins are not equivalent to paper money as far as they are physical characteristics are concerned. They are private. They are not issued by a state authority. The transfer happen electronically, so you can have a global network of transactions in a matter of minutes. The exact time has to do with the internal mechanism of each blockchain. And another interesting thing is that under certain conditions, you cannot have fake coins, or okay, there are some type of attacks like the double spending problem, which is successfully handled by Bitcoin. Those attacks can happen under certain conditions, but the take-home message, the practical message is that you are safe, more or less. So we have another interesting characteristic of Bitcoin is that the total supply is fixed, and this has been set equal to 21 million coins. The central banks or other monetary authorities cannot control this supply, and this characteristic gives some interesting features to this coin, which affect the price, because as having set the supply, having fixed the supply, then this asset becomes more or less, as the time passes, rare, and this affects the price. It's unlikely to have inflation-related effects. practically speaking, anyone with a computer, anyone having a networked computer can set up a Bitcoin address and enter the space of Bitcoin and start conducting transactions. Those transactions under the vision of Bitcoin and blockchain in general is those are transparent. So the Bitcoin does not guarantee full anonymity. Okay, is near to anonymous. Many times we call it pseudo-anonymous, and gives you under this pseudo-anonymity the ability to conduct transactions without passing through traditional financial channels like central banks and other monetary authorities. Yeah, this is already this is also indicated in this slide. Nowadays, many people around the globe are already using Bitcoin and similar cryptocurrencies as a medium for exchanging assets without the involvement of governments. However, in some cases, those transactions are subject to some, this varies country per country, control. So this is the coin, the crypto coin part. Let's see a series of technical characteristics that enable the creation and the operation around those digital assets coins. So every transaction is being recorded into, according to a transparent way, into a distributed ledger. This ledger is shared. Identical copies exist across the peer-to-peer network. This is time-stamped. This is of crucial importance because the chronological order of the transaction is very, very important. Is append only. You cannot erase or modify an entry in this ledger. Strong cryptography is employed for securing the system, and a very, very interesting functionality is that this digital machinery can be programmed using what we call smart contracts. Actually, smart contracts are computer programs like the traditional computer programs. However, instead of running in your PC or on a server, those programs run on the blockchain. I said that the smart contracts are interesting and very, very useful because you can implement your application, your business logic using the expressivity of the programming language, and this enables the creation of a decentralized application. This is beyond just doing simple financial transactions like transferring coins. You can create applications and dealing with auctions, polls, etc. Even more advanced things like the relatively new area of decentralized finance, where you can have a wealth of applications having to do with financial operations. So I think what I was describing before is depicted in this figure, where we have the traditional way of doing business on the left side, where 4 banks are connected through a central clearing house, where a centralized ledger is kept. So this traditional centralized model can be changed in the world of blockchain. We can have the decentralized, distributed, and decentralized version of it, where each bank can connect with any other bank, and their common, let's say, their integrator is the ledger that is being shared. So a ledger, you can assume that a ledger is a digital medium where all transactions are being recorded. You can think of decentralized database or decentralized file system or something similar. The implementation details vary from blockchain to blockchain, but this is the basic idea. Examples include examples that go beyond the Bitcoin use case include keeping some citizenship records, up to land registry, medical records, etc. Yep. And some more details are given in this slide, where it's exemplified why no central records are needed. And this is achieved by having many copies of the ledger distributed around the world, around the network. So let's see a simple but insightful, informative example. Assume that Helen was to send some money to Mary. Mary is her daughter who studies abroad. So bookkeepers check if Helen has enough money to carry the transaction, and if this condition is satisfied, then the transaction is conducted and the records are updated. So this is done by the nodes who run the network. There is no way to do a fake transaction. If such an attempt is noticed, I'm just describing it using plain terminology, then the transaction will not be accepted. Some interesting terminology here. Typically, Bitcoin with B, the first letter of the word in lowercase, refers to the coin, while capital B refers to the network. Address is the digital location where Bitcoins can be stored. Blockchain is the whole machinery that hosts the ledger, the Bitcoin, the network addresses, etc. While the transaction, it's used according to the traditional sense, an operation that is being recorded on the blockchain. So something I think basic but quite important: Bitcoin is not the same of blockchain. Bitcoin is a currency. It happens to have blockchain as the underlying structure, but blockchain can be used in many other applications. One of them is what we have done in the EUNOMIA project. Blockchain can establish trust between unknown parties, eliminates central authorities, intermediaries, and overall, it's a peer-to-peer decentralized system. It is important just to keep in mind that as far as cryptography is concerned at the core of Bitcoin, we have the idea of hashing for securing things. One of the techniques that are being used is a SHA-256, and cryptography is used at various levels, from encryption to decryption and other parts of the overall pipeline. Each block now a few words about the internal representation of storage. A block of transaction, a set of transactions is packaged into blocks. Those blocks are linked together according to a chronological order, while the links between the blocks are almost impossible to be altered. And this idea is what it gives security to the system. Okay, how the validity of those transactions and in general this representation is achieved is through consensus. So we have the concept of consensus algorithm. Okay, a consensus refer to the consensus that is achieved by the members of the networks regarding the validity of the transactions and the related entities. The most widely used nowadays is the proof of work. One of the debates around proof of work is that it requires a lot of computational power, and this has an environmental consequences. This is can be a very, very long discussion, but this is a nice point to lead us to the idea of proof of stake. Is something that major blockchain networks are considered nowadays, and the idea here is to give control, let's say, to the overall consensus as a function of the stakes that are as a function of your stakes or of your cryptos that are staked on the blockchain of interest. So what matters most is not the computational power that determines the performance in proof of work. What matters most for the case of proof of stake is your stake. Proof of stake is expected to be, at least for environmental purposes, more efficient compared to proof of work. But again, this environmental dimension is an open issue, which is determined by many factors, and this can be a very, very long discussion, just giving the basic ideas here. And we conclude by those references here that include some basic pointers into the broader blockchain literature. And thank you very much. Again, this material was prepared in the context of the DLT for All Erasmus Plus project. Is a joint work between the partners that you can see in this slide. Thank you very much. And I'm ready to take any questions. Otherwise, I can pass the floor to my colleague Klitos, who will talk about, I think, a more interesting, a more modern and interesting application of blockchains.
Thank you, Leah. Thank you for this introduction to blockchains and the fundamental concepts of blockchains. I think we have time for questions before we proceed to the next part of this session. So I would like to invite the audience in case they do have any questions. We can take them now. We have been also responding to a couple of questions from the audience. There is a question with regards to the carbon-free blockchains. So basically it depends on the consensus algorithm. And if the consensus algorithm is based on a traditional BFT or within the family of BFT algorithms, a POS proof of stake algorithm is definitely not that resource intensive and not that energy demanding. So there are several blockchains out there that are using a proof of stake kind of family of algorithms, consensus algorithms. Some examples could be, for example, Avalanche, Matic, Binance Smart Chain, and others that they mostly use POS. EOS is using POS, Tezos, and others. Depending on the consensus algorithm, there are just too many to mention now. Any other questions?
Also, is my mic open?
Yes.
Yeah. Also, I'm seeing a comment about what actually the blockchain is. It was answered by Euclides that is if we consider blockchain from the view of data structures, I mean data structures according to the traditional sense of used in computer science. Yes, this is a reversed linked list is it's
So basically, there have been some concerns in the past with regards to the proof of work, and that's why we've seen the evolution of blockchains to the newer generation of blockchains, which are utilizing consensus algorithms that are not that energy demanding. However, recently, due to a tweet of Elon Musk, this subject was surfaced again. And there have been some discussions with top mining facilities, especially in the US, and they have been committed into reporting their dependency on coal, etc., with regards to their energy demands. And I guess that soon we will have some updates with regards to that topic as well. As I've said in my previous response, it depends on the consensus algorithm. However, the proof of work algorithm, the Nakamoto consensus, as we refer to it, has the capability of scaling to thousands of nodes. Although the scalability in terms of the throughput of transactions is quite low, for a public blockchain, it's actually solving this issue, and it provides a similar attack mechanism for such systems. So it was an ingenious idea, and I think that there is value for closely understanding the usage of proof of work in public blockchains, especially. Okay. So in terms of energy, yes, as I've said, there is another question again on the same topic. Proof of stake are not that energy demanding, and also there are some variations of consensus algorithms, especially from the area of distributed systems. I mean, BFT family of algorithms that are being utilized and adapted in a blockchain environment. So it depends on the use case, Ilya. And we've seen that most of the private chains are using POS. There are public ones that are using variations of BFTs, etc. It's a great topic. So I will move on to Eunomia, though, since this is the topic of today's discussion. And I will be sharing my screen. So there is a question with regards to Eunomia. So let's get to this question before we move on. So basically, we are using a private implementation of a blockchain in Eunomia. We are using a Hyperledger fabric, which uses a BFT a consensus algorithm, which is not energy demanding at all, for the underlying, if you like, blockchain layer, blockchain infrastructure for Eunomia. And I will explain in my presentation on what, on how we are leveraging on this technology for this particular use case. Okay, before I jump into the presentation, I would like to invite everyone to this article that we wrote explaining on how blockchain is being utilized as providing data attestations for Eunomia, and also as we call it, the task machine layer for Eunomia. You can find more details with regards to the Eunomia project, which is funded by the European Union, on eunomia.social, our website, and we have some very interesting articles on the blog for you to check out. So with regards to this part of the presentation, I would like to firstly introduce Eunomia for those that you are not aware of this project. So our aim with Eunomia is to provide tools that assist users in following guidelines for information hygiene. Eunomia contributes to what we refer to as media information literacy, and it's a project that aims to foster awareness and critical thinking skills for the users of such social media networks. Actually, Eunomia empowers social media users to critically assess, by using Eunomia's tools, the information that they consume. Therefore, they can act as human trust sensors in the network. This is what actually Eunomia does. So Eunomia, in a sense, it encourages active participation to social media users in order to help them to stop spreading misinformation. And as I've said, practice, guidelines for building information hygiene, as we refer to the project. As it was mentioned previously, this project is supported by a consortium of partners under the Eunomia project, and today's MOOC webinar has been powered by DLT for All and also the University of Nicosia. So having introduced Eunomia, so in my next slides, I will be presenting at the abstract level some of the fundamental architectural components that we are using and leveraging in Eunomia. What we have been trying to achieve here is to enable a blockchain infrastructure to act as a mechanism that provides data attestations to the posts. It guarantees the integrity of the information from the posts, and it also provides a layer for governance control mechanisms. We imagine that the Eunomia is a decentralized and distributed network, and participants to the network, they will be running the Eunomia service node, as we call it, which is a wrapper of various services. And blockchain could also be utilized as a governance control mechanism of who is actually joining the network in terms of participating into offering Eunomia services. So basically, our architecture is modular in order to be able to support future development and new services. And I will also be describing, as I've said, some governance control mechanisms. The idea here is that we will allow several entities to join and participate into actually building and supporting the Eunomia service node. And therefore, there will be some governance mechanism governing the network, the participation to the network in a decentralized fashion, similarly to a decentralized autonomous organization. At the same time, the blockchain offers security in terms of providing data attestations of the posts and the information that has been exchanged within the Eunomia network. So in a very high level, we have the Eunomia service node, which actually provides the services under Eunomia. Users are able to access these services by using the digital companion client. It's either the mobile application or the web interface. Actually, the Eunomia service node is a layer that connects to various decentralized social network platforms such as Diaspora and Mastodon. At the moment, we have been testing both of them, and the link that we shared in the chat it integrates to the latest version of Mastodon. So please do check it out. I'm just noticing here that this is a highly in development environment. It's a testing environment, so some of the features may not be working 100% there, but we have been improving and we have been integrating all the services, and we will be able to be 100% up and running very, very soon. So as I've said, we imagine a federation of various service nodes that run and support Eunomia, and users are able to access by using various interfaces. So we propose an architecture which is very much data-driven. At the lowest level, we have Diaspora and Mastodon as the source layer of the information, and then we built on top of it a layer architecture for processing the data, for aggregating the data, another layer on information fusion and knowledge extraction, and other layers in building the information cascade as mentioned by Sula, and the AI algorithms that do the knowledge extraction there. And of course, the application layer, which is the interfaces that provide access to the users. On top of that, we have some security and privacy layers and transparency and trust layers that are built on blockchain. All the data are actually made persistent in using an IPFS service, which is a peer-to-peer storage service. Actually, we have been experimenting with OrbitDB using IPFS. Attestations of the information are anchored on a Hyperledger Fabric blockchain, so that the information is guaranteed, traceable, and auditable. So let's zoom into the Eunomia service node, and in particular the component that relates to the ledger service. So overall, the ledger service is a component that instantiates the implementation of the blockchain infrastructure, which, as I mentioned previously, it assures the integrity, the transparency, and the consistency of the information that is stored in the peer-to-peer storage. So there is a close collaboration of the Eunomia peer-to-peer storage layer and the ledger service that runs the blockchain infrastructure. So we there record some metadata with regards to the content, ensuring the transparency and consistency between the Eunomia nodes. The actual data are stored in a secure storage using OrbitDB, which is a database instance, which, as I mentioned, it utilizes and builds on top of the IPFS, the interplanetary file system. So it's an append-only peer-to-peer file system for spreading data and making data redundant. At the same time, the framework offers mechanisms for privacy. So we have some privacy and components there. We also built some digital signatures and cryptographic hashes. And for the purposes of Eunomia, each information element is stored in the peer-to-peer distributed file storage, and a specific token is generated by the storage server and recorded to the blockchain ledger to provide the data and attestations that we are looking for. This is a mechanism that we implemented in order to ensure the integrity of the data being stored. There are also some other services I don't want to get into detail. I will also be mentioning the voting services, as I mentioned previously, that allows for providing a decentralized, if you like, mode of governance within Eunomia ecosystem. So in essence, the blockchain layer instantiates Hyperledger Fabric. We have implemented chain code, which is a smart contract that implements the various controls and transaction logic for the object states. And we also implemented mechanisms that provide the governance control and the functions that enable this governance control within the blockchain infrastructure. For example, these mechanisms can allow, for example, the addition of an organization or within the Eunomia network, or the removal of an organization within the consortium. Again, voting will be taking place and the smart contract will be executing whether an action will be executed on the network for either adding or removing an organization from the Eunomia. And this is not for the user level. This is actually for building the Eunomia network, the Eunomia ecosystem. As I mentioned, in a more decentralized fashion, similar to a distributed autonomous organization. So other actions that the Eunomian governance will approve or disapprove is whether an update will be executed on a smart contract. As I said, whether an organization would be joining or removal of some organization, and also on the policies of accepting or rejecting a smart contracts. So basically, this governance functionality will be applied to the rest of the Eunomia service components through the linkage of the blockchain infrastructure and other services, such as, for example, the tracking service and the peer-to-peer storage. And these components actually depend on the blockchain infrastructure in order to validate the client or the service authorization and check the integrity of the data, as previously explained. So in a more detailed view, the role of the blockchain infrastructure component in Eunomia is actually twofold. Firstly is to provide the integrity and the assurance of the information that is stored by the distributed peer-to-peer file storage service. And secondly, to provide the execution layer for the network's governance processes. So, and we are building those, the trust and transparency layer and the governance layer on the Eunomia's blockchain network, as we depicted in the previous slide. So the main idea here is that, again, we are leveraging on the blockchain network to provide a trusted service component for ensuring the integrity of the information that is being recorded and distributed with the proper hashes and timestamps. So each participant in the peer-to-peer network of Eunomia will be able to access this information and query the ledger along with the previous states, and making sure that the transactions are validated and confirmed by the rules of the code. So in essence, I think I'm finishing up. Users post AI models and users trust are all stored within Eunomia's fully decentralized peer-to-peer infrastructure, which gives control to those entities controlling the data, and a blockchain that ensures that there is integrity of the data being used. The focus of this webinar today is not to touch upon the AI modules, but as I've said, Eunomia is providing tools in order to build up confidence on users on how to consume information aligned with the guidelines of this information hygiene, as we previously mentioned. Concluding, I hope that you found this material useful. I think that we have time, Elias, for taking questions. I also wanted to share with the rest of the audience that we currently been building and integrating Eunomia's components. You can register to our efforts. You can register to the Eunomia instance that is currently up and running. It is very user-friendly interface that allows users to navigate through its own environment and observe the posts that are coming and streamline from his or her timeline, coming from a Mastodon node. There is an icon there verifying that the data integrity of this post has been confirmed. This is not to confirm that the content of the post with regards to the misinformation, but this is to show to users that this information has been, the data integrity of the information has been verified using a blockchain layer. You can navigate through the blog posts here, and there are several mechanisms for trusting and distrusting the information, going back and tracing the posts, the similar posts that relate to that particular post. And as I mentioned previously, the purpose of Eunomia is to improve the decision-making of the user in terms of judging the information that the user has been consuming using the tools offered by Eunomia. So please do check it out. This is, as I mentioned, a testing environment. You can also post your own posts here and play around with the tools. And remember to go through this article and understand exactly how blockchain has been utilized in terms of providing the data attestations for the network. Thank you. And I think, Ilya, I think we have time for questions. As I mentioned, we are using a Hyperledger Fabric version 2.3. So information with regards to the project can be found on the Eunomia social. Okay, as I mentioned previously, the purpose of Eunomia is to provide the tools that assist users in following what we refer to as information hygiene guidelines and making them more practical and easy to adopt. So the purpose of Eunomia is to enable users with the tools for improving their decision making or judging the information that they have in hand, and critically assessing and consuming this information, acting, humans will be acting as trust sensors in the network. And we encourage the active participation of social media users in order to help to spread, to stop spreading misinformation in social media by utilizing the tools offered, such as the information cascade and various mechanisms that users can vote on the content in terms of their trustworthiness and act as a reference in their network. So this is the purpose of Eunomia. We've shared the link to the test environment. So I will also be sharing the test environment here again. So the way we have built Eunomia, it's a very modular design that will allow extensibility to other social media platforms. Currently, we have been experimenting with Mastodon and Blasting News. So I'm sharing again the link to the testing environment, the testing instance. So yes, the idea is that we will be expanding Eunomia to other social media networks in the future. Actually, we're currently been discussing on how to further expand our efforts along with our partners and the guidance of the coaches from the European Union in expanding the Eunomia's ecosystem and encourage the participation into further extending the network and also to other organizations. Yes, we intend to share this video, this recording after this session. Any other questions? Yes, we will be sharing the material and the video recording. So, Ilya, do we have any other questions? I think you are muted.
It seems not. I don't know if probably, I don't know if you have already mentioned. Please stay tuned on the Eunomia front as the project starts to converge into the mature version of the platform, etc. More interesting things will be announced there. Correct, Klidos?
Exactly. I'm also sharing the blog of Eunomia so that you can read through how blockchain can act as a task machine for this particular use case. And also the main link of Eunomia Social, where you can follow us and find more about the project and the consortium of people that been working on this project, materializing this project. There is a question from an attendee with regards to a potential collaboration at the research level. I would like to invite everyone to going through our job posts at the University of Nicosia under the Institute for the Future. We have some openings at the moment with regards to people that they would like to get involved with the Institute in general. I will be sharing also the opportunities for collaborators, either under the career opportunities and also the collaborators under our research laboratory. So you can find more about the team at the University of Nicosia and also the laboratory that works on materializing the technical aspect of the project in terms of the team that of the University of Nicosia's team. So as I mentioned, the actual data are stored on OrbitDB, which builds a layer on IPFS. And actually, a Eunomia service node runs an OrbitDB client and utilizes the peer-to-peer, the capabilities of the peer-to-peer storage network. This is the main idea. Attestations of those blog posts will be added and pushed on the blockchain list. Okay. Any other questions? And as I mentioned earlier, we will be sharing this recording. There is also an interesting question with regards to linking Eunomia to identity. Yes, we have been discussing this internally. This is something that definitely we will be considering in the next iterations of Eunomia and building the IDs and the centralized identification mechanism on Eunomia.
Great. It seems that we have no further questions. So we may say thank you. Please stay tuned on the Eunomia website, as well as follow the interesting links sent by Klitos above. And once again, thank you very much.
Thank you so much all for participating to this session. Okay, I think we are concluding. Thank you very much. We will be sharing this session along with the slides publicly to everybody. Check out our blog posts and also our Twitter account for more details on how we are building Eunomia and evolving Eunomia. Thank you very much.
Thank you. Bye-bye.